Hello everyone, welcome to Equal to, and in this video we are starting the second chapter of class 9 science, which is matter around us pure. So I hope you have learned the first chapter of class 9 science. I'll link the playlist for the first chapter here. If you haven't watched that, you can go and watch that. And there is also the revision video, that the last minute revision video that summarizes everything that we have learned in chapter 1. So you can also watch that just before learning this video. Okay, now we are moving on to the second chapter of class 9 science, which is matter around us pure. So what exactly is pure? So in general common man's term, we call something pure if it has no adulteration. So let us say we have ghee or we have milk. So when we call milk or ghee pure, we say that because there is no adulteration in it. Okay, so adulteration in the sense, probably in rice you might have seen some stones there, so that is adulteration. So those sort of things. Okay, to increase weight they must have added something. That is something that we call as adulteration. So if that is not present, we generally call it pure in common man's term. But actually milk and ghee are not pure. They are in fact mixtures of water, fat and proteins, and there is a lot more present in it actually. So it's just a mixture of all those things, and these things are not actually pure substances. Okay, now we'll learn more about these things and how materials are things that we use in our day-to-day life. Are they really pure? Are they really a mixture? So we'll be learning more about these things in this chapter. So we are going to mainly focus on mixtures and pure substances in this chapter. Now we have said that it's actually not pure. So ghee and milk, they are actually not pure and they are actually mixtures. So what exactly is pure in your terms? So disregarding the common man's term, what exactly is pure? A substance is considered pure if it contains single type of particles. I hope, I think you might not have understood this clearly, but by the end of this video, you'll probably get to know how we define this. A substance is pure if it contains a single type of particles. So it might not make a lot of sense now, but please bear with me, you'll get to know it. So before getting into the actual meaning of pure, let us say that what a mixture is. Okay, so now we know that milk and ghee, they are not actually pure and they are mixtures. So what exactly is a mixture? A mixture is it contains one or more pure substances. Actually, just ignore the one substance. If it's just one substance, it's pure, right? So if it has more than one pure substance in it, we call it a mixture. So let us say we take seawater. So seawater is a mixture. Seawater contains sodium chloride in it, and it can be separated from seawater by the physical process of evaporation. Now the things that you have to note here is that it's a mixture and it can be separated using a physical process. Okay, I'm just quoting with my hands here, just to emphasize it, that it can be separated using a physical process. Okay, so that is what we call a mixture. It's a combination, it's a collection of more than one pure particles, pure substance, and it can be separated by a physical process into its chemical constituents. Meaning sodium chloride is a pure substance. H2O, which is water, is another pure substance. Now don't worry about the chemical formulas or things like that, chemical symbols, don't worry about it. Just pure water we have, and we have sodium chloride, which is salt. Now it is combined in seawater and it can be separated using the physical process of evaporation into its chemical constituents, meaning sodium chloride and H2O. They can be separated using a physical process which is evaporation. So seawater is actually a mixture. Another example of a mixture could be salt and sugar combined together. Okay, salt and sugar, when you when you pour both these in a basin, in a vessel, it's a mixture of salt and sugar. You cannot tell it something else, right? Because we don't have something that is a combination of salt and sugar. It's just a mixture of salt and sugar. Okay, so a mixture is just a combination of more than one pure particles, pure substance in it. That is what we call a mixture, and it can be separated using a physical process. Now in the case of seawater, we were able to separate it using evaporation, but there are more ways to separate mixtures physically. We will be learning more about that as well in this chapter. Now, what are the types of mixtures? Now we have 3 examples. The first one, we have a beaker and we add 1 spatula of copper sulfate in it and mix it very well. And in the second beaker, you are going to add 2 spoons of copper sulfate in it and mix it well. And in the third, we have 2 china dish, let us say 2 china dish or just a glass plate, and you are going to mix potassium permanganate with copper sulfate. You are going to mix these 2 salts, these 2 crystals together. Okay, now these are the 3 things. Now what would be your observation? The first mixture, the copper sulfate would have colored the entire water, and the second example, we added 2 spoons of copper sulfate, right? So it would have a darker color when compared to the first beaker. And the third one, it's just a mixture, they wouldn't mix well. Copper sulfate is blue in color, potassium permanganate is purple in color, and they don't get along, and you end up with a mixture that are visually distinguishable. There are 2 types of, you can clearly see that it has potassium permanganate and it has copper sulfate. It's visually different, they don't completely mix together. So this is what we use to generally distinguish between mixtures. So the ones that are indistinguishable or that dissolve, like in the case of copper sulfate in water, they dissolve well and you are not able to distinguish between the constituents of that mixture visually. That case we call it a homogeneous mixture. And something, if it's able to be visually distinguished into different substances that are present in its mixture, it's what we call a heterogeneous mixture. So in the case of copper sulfate and potassium permanganate, you were able to visually distinguish between the copper sulfate substance and the potassium permanganate substance present in that glass glass plate, right? So this is an example of heterogeneous mixture because you are able to visually differentiate between it. And another example could be some iron fillings or iron nails put in common salt. So this you can see it's clearly a mixture because you can clearly see that the iron nails don't belong with salt, obviously. Okay, so it's clearly a mixture. So basically there are 2 types of mixture. One is homogeneous, in which you are not able to clearly distinguish between the constituents of the mixture. But whereas in heterogeneous, you are able to distinguish between the constituents because there is a visual element to it. You can visually distinguish between them. In the case of iron fillings and salt, it's a clear example. The iron fillings are clearly visible in salt. So that is all we have learnt in this video. If you have any questions, please put them in the comments. I'll get back to you as soon as possible. And also, if you want to revise the previous chapter, I'll give a link. It will have a playlist. It will have every single concept in the previous chapter and also all the questions, so you can learn them. And also there is a short summary of 12 minutes. You can go through that just to revise everything. And if you have any suggestions, put them in the comments. If you have any doubts, put them in the comments. Please feel free to do so. And just maybe if you enjoyed the video, give me a like and subscribe to Equal To. Thank you so much for watching this video. See you in the next one. Bye for now.